In this video, I'm going to go over a few examples from the notes from 1.4 on perimeter and area in the coordinate plane. So I went ahead and filled in all of the perimeter and area formulas, which I'm hopeful that you will have remembered from your days in middle school. But if you forgot or need a refresher, here they are. So make sure and put them in your notes so you can refer to them. We are not going to give you these. So the expectation is that if I ask you to find the perimeter and area of any of these shapes, you should be able to do that without formulas given to you from the teachers, okay? You'll also notice as I go through this video that I've worked out examples ahead of time, so I'm not going to do all of these questions. The video would be quite long and people would not watch it if it's that long. So feel free to go back to the key, which is on Canvas, to check out my work on these. So I'm going to focus on doing number 2 and then number 3 and then the very last one, which I think is the most challenging. So let's start with number 2. Number 2 says to find the perimeter of this triangle DEF. All right, it gives us the vertices. So I'm going to first go ahead and sketch triangle DEF. So we have 1, 3. Go ahead and label it when you sketch it. E is 4, -3. So that's point E. And then finally we have F, which is -4, -3. So there's F. Now I'm going to use my ruler in this app to go ahead and connect these to make the triangle. Again, doesn't need to be perfect, but if you do have a straight edge available, like your protractor, or if you have your Falcon card, you can use that as a way to connect the dots here to make this triangle. Okay, so now we're only being asked to find the perimeter here. So I just need to find the distance between each of these points to find my 3 different side lengths and add those together for the perimeter. Now one of them is actually pretty straightforward. I notice segment EF is horizontal. So I'm just going to count to figure out what this is. So the distance between E and F is 1, 2, 3, 4, 5, 6, 7, 8. So this distance is 8 units. Okay. Now for the other ones, since they are not horizontal or vertical, I am going to write down, because I'm going to use it, the distance formula. All right. So if you forgot this, you should in your binder have this reference sheet, which includes it. So take that out, because we're going to use it to find my 2 other side lengths. So I'm going to start with DF. All right, so finding the distance formula here with DF, I'm going to do -4 minus 1, all of that squared, plus -3 minus +3, all of that squared. Now to do my simplifying, -4 and a -1 is a -5. Notice the parentheses are still around that negative. -3 and a -3 is -6, and we're going to square both of those. So they'll both become positive of 25 plus 36. All right, and when I add those together, I get the square root of 61. Now 61 is a prime number. I cannot reduce that in terms of just 1 and 61. I have no other factors. So I'm going to write down that segment DF is the square root of 61 units. Okay, let's do the same thing, but for my other side length, which is DE. All right, so doing DE, I'm going to have 4 minus 1, all that squared, plus -3 minus +3 squared. Do my subtraction, that is +3 squared, and this is -6 squared. Squaring those will become 9 plus 36, which is the square root of 45, and that actually can be reduced. I can break that down into the square root of 9 times the square root of 5. So simplified, my side length DE is 3 times the square root of 5 units. So I'm going to write up here, DE is 3 root 5. Now I have all 3 side lengths. So to find the perimeter, I'm going to add all 3 of those side lengths together. Now you'll notice when you look at all 3 of them is that I actually cannot add any of these together, right? 8 square root of 61 and this 3 times the square root of 5. None of those can be combined. So actually my answer is going to be all those added together. So 8 plus the square root of 61 plus 3 root 5 units. So this is the perimeter of that triangle. All right, let's move on to the next one, number 3. So number 3 says to find, this time, the area of a parallelogram. So let's go ahead and graph this parallelogram. So we have point J, which is going to be negative 3, 5 up here. We have point K, which is 1, 5. Point L, which is 2, negative 1. And finally, point M, which is negative 2, negative 1. All right, I'm going to use my ruler again to connect these. I got a couple of horizontal ones here. Those are actually the trickiest for me to do. Okay, we'll do this one. Okay, turn it to get my other side lengths of this parallelogram. And then finally, my last one here for JM. Perfect. All right, so there is my parallelogram, and we just want to find the area. So if you need to go back to your formulas up here on that first page, for a parallelogram, the area says base times height. So I'm going to write down the base times the height. Well, the base actually is this segment here, LM or ML. So I'm going to use that as the base, and I'm just going to count to find that distance. So 1, 2, 3, 4. So that is 4 units for my base. And then for my height, I'm going to choose point M, but you could use point K, right? You're just counting the distance from this base to the other side of the parallelogram across from it. So I'm going to count from M till I hit segment JK, which is 1, 2, 3, 4, 5, 6, right? So this right here, I'm going to use as the height. All right, so my area is going to end up being 4 times 6, which is 24. So the area is equal to 24 square units. All right, what you're going to find out with these questions is that a lot of times area actually is a little bit quicker or easier to find because with perimeter you have to add up all the sides, and a lot of times you have to use the distance formula. Okay, so that's number 3, the area of that parallelogram. Let's jump all the way to the last one. So you'll see I've done 4 already. This will be on the key. I've done 5 already. I even done 6. Let's do 7. 7 is, I think, the most going on here. And it wants us to find perimeter and area, so both things. All right, so I'm going to do perimeter first. It seems to be what requires the most thinking, or at least the most work with the distance formula. So the first thing I notice is that I do have some of these sides of this polygon are horizontal or vertical. So I'm just going to count to find those. So I know AF is horizontal. I see FD is vertical, and DS is horizontal. So I can actually just count. Don't have to use the distance formula. So let's do AF. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 units for that one. FD is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's 15 units. And I can put those up here. So that's 11. That's 15. And then DS is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 units. All right. Now, I do need, if that's 17, I do need to figure out distance for AG as well as GS. So I will be using the distance formula to figure out those 2 side lengths. All right. So get used to copying that down a lot. It's a formula that you're going to get, but you'll end up memorizing it because you use it so much. So let's start with AG. All right. So AG, let's get the order pairs for AG here. So A, that's going to be negative, looks like negative 6, comma 10. And then G is going to be negative 1, 2, negative 3, comma 1, 2, 3, 4. All right. So finding AG, I'm going to do negative 3 minus negative 6, all of that squared, plus 4 minus 10, all that squared. Negative 3 minus a negative 6 is really adding. So negative 3 plus 6 is a positive 3. And 4 minus 10 is a negative 6. So that's going to give me 9 plus 36, which is the square root of 45. We actually just did that one on number, I think it was number 2. And the square root of 45 reduces to, I'll show the work again. So this is going to be the square root of 9 times the square root of 5. I know the square root of 9 is 3, so this is 3 root 5. Now I know some of you, a lot of you in class, like to keep breaking down that 9 into 2 3s. That's fine. But when you have 2 3s, that creates 1 3 on the outside. So it's how your brain does it. That's totally fine. So this is 3 root 5. Okay, let's do GS. So GS is going to be, I need the order pair for S. That's negative, let's see, 10, 11, 12. 12. And then 1, 2, 3, 4, 5, negative 5. Okay, so GS, I'm going to do negative 12 minus a negative 3 squared. And then negative 5 minus 4 squared. So GS is going to be, let's see, negative 12 minus a negative 3 is really negative 12 plus 3. That's negative 9 squared. Plus negative 5 minus 4 is negative 9 squared. Oh, both of them are going to be negative 9 squared. So that's 81 plus 81, which is 162. All right, let's break that down. And this time I'll break it down. A lot of you guys like to just get it to its simplest number, so I'll keep doing that. So that's going to be 2 times 81. And then you guys like to do 9 and 9, and then you even like to keep going. Let me do the arrows so we know where we're going. 3 and 3 and 3 and 3. Okay, so I've told students that came into office hours that do it this way, totally fine to do it this way, but circle the numbers that when you multiply them back together are going to give you 162. So we know that all of this is going to multiply to give us 81, and then 81 times that 2 will be 162. So since I have 2 sets of these pairs of 3s, I know that on the outside, I'm going to not only just have 1 3, I'm going to have a second 3, and they have to multiply when you pull them out. So 3 times 3 gives me 9, and that's going to be 9 root 2. Okay, so GS is 9 root 2. So for the perimeter, if we want to go ahead and write our answer, we're going to be adding together all of these numbers right here. Now you'll notice when I highlight these numbers, 3 of them are whole numbers, so I can add 11 and 15 and 17 together. When I look at my radicals, they do not each have the same number inside the radical, so I have to keep those separate. So just be careful when you're doing this for the test that you make sure you keep those separate if they don't have the same number inside the radical. So we have 17 and 15 is 32, 32 and 11 is 43, plus, I don't care the order which you do these, it's your call. So 3 root 5 plus 9 root 2 units. So this is the perimeter of this polygon AFDSG. Now let's do the area. I'm trying to show you where I'm changing here. All right, so when I do the area for these, I'm going to basically cut this figure up into shapes that I know how to find the area. So I see here that if I draw a line right here, that's going to be a triangle. If I draw a line there, looks like it's a rectangle. I'll confirm it's a rectangle or square in a second. And then this one here would also be cut up into a smaller triangle and then a smaller rectangle. All right, and I know how to find the area of those because I have the formulas on that first page. So if you need to refer to them, please feel free. So let's do some area here. I'm going to start with this big triangle, so I'll just call it the larger triangles. The big triangle is base times height over 2. So my base, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. The height is 1, 2, 3, 4, 5, 6, 7, 8. Also 9. So I'm going to have 9 times 9 over 2. So that's going to be 81 over 2. And you can leave it as 81 over 2. I'm going to end up adding this together. And because it's divided by 2, I can deal with 0.5 when divided by 2. So I'm going to go ahead and put it as a decimal. But feel free to leave it as a fraction. So 40 times 2 is 80. So 40 and a half would give me 81. Okay? So that's the big triangle area. Let's do the little triangle. So we'll say the little triangle. So again, base times height over 2. I'm going to choose the bases over here. So that's 1, 2, 3. The height is 1, 2, 3, 4, 5, 6. Okay, that one's going to be an even number there. So 3 times 6 divided by 2, that's 18 divided by 2, which is 9. Okay, so next up, I'll choose, let me confirm it's a rectangle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's 8. Okay, good. So I'll choose the big rectangle. Let's do big rectangle. All right, and that's just going to be length times width. All right, so my length I'm going to choose is 1, 2, 3, 4, 5, 6, 7, 8. Or you could say you already used 9 for part of SD, so then the other part of SD has to be 8 to add up to 17. This up here is going to be the same width as my height that I used on the big triangle, so that's also 9. Count to confirm if you want. So 9 times 8 is what I'm doing for the area of the big rectangle. That's 72 units, or square units. Now let's do the small rectangle. Also length times width. And so I'm going to choose that same length of 8, right? 8 plus 3 gives me 11. Actually, let me put it here, 8. And then for my width, I need to use 6, because 9 plus 6 gives me 15. Count if you need to. 1, 2, 3, 4, 5, 6. Perfect. So it'll be 8 times 6, which is 48 square units. So my area is going to be 40.5 plus 9 plus 72 plus 48. All right, so let's see if we can do that in our head. So I'm going to do 72 and 48 first, because those 8 plus 2 is going to be 10, so that's going to be 120. 120 plus 9 is 129. So 129 plus 40 and a half. If it was 130, that'd be 170 and a half, so take away 1, so 169.5 square units. And that is the area. All right, guys, I know that was a lot of work, a lot going on. If you have any questions on this or on the homework, please stop by and see us for the office hours. All right, see you soon.